Hello, everyone, and welcome to the ADAPT training series. We're so happy to have you join us today. My name is Heather Harris. I am an Alteryx ACE, and I am also the practice director for data science and analytics for PK Global, who is one of Alteryx's premier partners, and we just have a terrific partnership. Today, we are here to learn about optimization, and specifically we're going to dive into prescriptive optimization. And those words for people who are newer to Alteryx can be a little bit intimidating at times. And so we're going to demystify those words today and break it down for you. What does this really mean? What I am going to let you know is that we are going to take you back to high school algebra. So get ready to have a math refresher as well, and how we're actually going to use things you thought you would never use in high school with Alteryx. So really, optimization is about finding the best outcomes for your business problems. So something like, oh, I need to maximize my profit, or I need to minimize the cost of staffing. And so we're going to do that using, I don't know if you remember back in the day, this idea of systems of equations. It sounds really intimidating, but we're going to make it super simple for you today. So when we're doing optimization problems, there's three key concepts. There's your objective, there's your limits, and there's your constraints. And we're going to show you how we actually figure out what those are and apply this concept called linear programming, which is really what this optimization tool in Alteryx is all about. So when we're doing an optimization problem, there's several processes. We prepare our data for the optimization tool and algorithm. We actually input a file, or actually I'm going to show you how you can do it manually. And we're going to do it manually actually so you can really understand the concepts and break it down. And that's through the configuration itself. So let's take a look at a business case that we would call prescriptive optimization. So my business problems, I really want to maximize revenue. And the things that I have available to me when I do that in this, it's going to be a clothing manufacturer, is I'm going to have my raw materials, and I'll have my required materials for whatever it is I'm producing. So there'll be requirements around that. And then I have however much I can produce. So we'll call that production capacity or throughput. And then the price of the merchandise itself. So let's go ahead and we'll walk through what those four things are that are part of my business problem. So I have raw materials. In this case with clothing, I have a certain amount of cotton and I have a certain amount of polyester, specifically 750 square feet of cotton and 1,000 square feet of polyester. So that's just kind of a known that, my company said, hey, here's what we have available. Now, we want to make some pants and we want to make some jackets, and so we also know what's required to make a pair of pants. Well, it's 1 square feet of cotton and 2 square feet of polyester. And what's required to make a jacket? It's 1.5 square feet of cotton and only 1 square feet of polyester. So now you're probably starting to get a sense of, oh, okay, I only have so much material, raw material available. And this is what it takes to make a pair of pants and a jacket. And we're going to want to make as many of those as possible because that's what's going to maximize our revenue on these items. And then we also have some factory requirements or some factory constraints, if you will. And we know that our factory can only make a maximum of 400 jackets a day. And because of the way our business is set up in our factory, we always want to make a minimum of 200 pair of pants a day. So this is just another thing that our company has told us about this problem to solve. We also know that there is a fixed price on our goods. So in this case, our pants are $50 and our jackets are $40. So the final thing is just like, let's bring it all together. Let's actually ask this in a question. And this is something that will be true of analytics, and especially if you want to move into predictive analytics and data science and machine learning is getting the question right. That's always key in these kind of problems. And the question here is, how many pairs of pants and how many jackets should I produce to maximize revenue? And I know it seems pretty basic in this case. It's pretty obvious. We kept it simple on purpose just to make sure you get the concepts. But all of the stuff we're going to go through today can be applied to much more sophisticated problems with many more requirements. And we're going to actually teach you how to bring those together so you can take this and extend it to more complex problems. Okay, so we went through the problem in business language and kind of the business facts that come in. And so now what we have to do is we have to frame it up as an optimization problem. And by getting our facts just right, we're well on our way, but now we really need to get it ready for the actual analytics. So there's this concept of variables. And variables are any part of those business requirements that are going to have a direct impact on whatever our outcome is. So that are going to have a direct impact on our revenue. You probably already have some ideas in your head about what those might be, but that's a great way when you're looking at a more sophisticated problem and you're trying to tease out all the information the business is giving to you is, okay, what about these things has a direct impact on the outcome I'm trying to get to? So in this case, if we look at our question, how many pairs of pants and how many jackets should I produce to maximize revenue? Well, our variable are the number of pants and the number of jackets. And we're going to assign those for simplicity to X and Y. See, I promised I'd take you back to high school algebra, and here we are. We're already talking about X's and Y's. And specifically now, we want to figure out what's our objective here. And this is where you get to do a little bit of mental gymnastics, and again, go back to that high school algebra. So we're going to figure out, how do I actually come up with my objective? And I'm going to call it the objective function. So if you think about it, if X is my pants and I charge $50 for a pair of pants, the revenue I get is 50 times X, the number of pants. And if I think about my jackets, and jackets are $40 a jacket, and I want to know how much revenue I get for how many jackets I produce and sell, that's my Y. And so my revenue is really just the 50 times the pants and the 40 times the Y, which is my jackets, and that's how much money I'm going to make on whatever I produce. Now you might remember, but wait, Heather, there are some things about this. We can't just throw in any X and any Y, and that's exactly what we're going to figure out today is, well, what do I want my number of pants and my number of jackets to be to get the most revenue out of this equation? And so now we need to kind of dig a little bit deeper. So what does affect our variables? What does affect the number of pants and jackets that I can actually make? And then for those of you who are following along, I'll just remind you this slide deck is available to you in the On24 platform here. So later on, if you want to go back and use this as a guide to help you dissect a problem, certainly you can do that. So I just thought I would remind you that it's available to you as well. So let's look at our constraints. In particular, I'm going to look at the materials constraints, and we can dissect these up different ways. But for cotton, we remember that we have 750 square feet available. We remember that pants take a square foot and jackets take 1.5 square feet. And then we can look at polyester the same exact way. We know we have 1,000 feet available. Our pants require 2 square feet, and our jackets require 1 square feet. So what you're probably seeing is really this is all about just laying out the facts and laying them out in a systematic way to get to our math. So I like
Heather, it looks like you're frozen. Heather is coming back, so let's give her a minute.
Can you hear now?
Yep, you're back now. It's still a little choppy. Maybe try turning off the one sec.
I will turn off my video, yes. There we
go. You're coming in
cool.
clear now.
Oh, much better. Thank you, Tuvi. And I apologize to the audience. Welcome to the COVID-19 world where internet, it gets slammed, and for whatever reason, our neighborhood has been having some issues in the neighborhood for the last few days. So I apologize, and thanks for your patience, everyone. Again, this is recorded and you can download this deck. So if you want to follow along later as well, you can. Tuvi, is it still coming in okay?
Yep, I hear you loud and clear now.
Perfect. That was probably the video. Great, everyone. So the meeting got stuck a little bit as we were talking about constraints, and really I was just saying I like to then take those constraints and put them in tabular form to help me keep track, and mostly because I'm a data person and I like tabular form data, but you'll see that this will help us later as well. Okay, so now the fun part, here comes high school algebra for you. So I've got it in tabular form, and remember we're looking at our constraints around cotton and polyester. And so now I have to figure out, how do I put that into an equation? So if we look up in our table, we see that we remember X is our pants, and we know that for cotton, it takes 1 square feet, and for pants, it takes 1.5 square feet. And all the cotton that we use, if we add those up, we have to come in under or at 750 square feet, because that's all we have available. So now we're actually making an equation out of our constraint. And we do the same exact thing for polyester. We know that we have 1,000 square feet of polyester, so the amount, whatever number of pants we come up with, it takes 2 square feet, and the amount of jackets we come up with take 1 square feet. So if we add up all that gets used into and put that in the equation, it needs to be equal or less than the 1,000. And so this is where we're going to use the power of the tool to help us solve these equations in a way that gives us our maximum output. Now, we are going to it manually first so you can understand the math behind it, because that will help you frame up more sophisticated problems later. But rest assured that even though we're going to do it manually to show how the process works, the whole power of the Alteryx optimization tool is to solve this for you when you have lots of variables and lots of constraints. So here we are, back to school. We did call this summer camp, Alteryx summer camp. So we're gonna do a little bit of summer school right now. So let's look at our linear equations that we just came up with. And we're going to do something called isolating a variable. So the reason we want to do this is we want to figure out a way to tie these two equations together. And to tie two equations together, you make them equal or around the same variable. So in this case, we're going to find out what is y for cotton and what is y for polyester, because then we can put equations together. So I'll kind of tease this out, and this is back to math where this was my original equation, x plus 1.5y has to be less than or equal to 750. In order to get my y all by itself, the first thing I want to do is subtract x from this side, which means I have to subtract it from the other side to keep the equation the same. So that you might remember how we do that. We subtract from one side and bring it to the other. So now the next step in order to get my y all by itself is to divide by 1.5, because then that'll just make it 1y. So if I divide my left-hand side by 1.5, I need to divide everything on my right-hand side as well. And that gives me 500 minus 2/3 x. Because remember, I divided, and when you divide by, we divided by 3/2. When you divide by 3/2, it's really multiplying by 2/3. I don't know if that's really bringing you back. But we'll do the same thing for polyester. 2x plus y is less than or equal to 1,000 square feet of polyester. To get our y all by itself, it's a little bit simpler in this one. We just have to subtract 2x from both sides. So now we have both of our constraint equations in the form of y. And to help us solve this in a visual way and see what's happening here in this optimization problem, we can graph these lines on a graph. And you might remember this idea of a line equation as y equals mx plus b. And the m, which here is 2/3, is your slope, and b is your y-intercept. So let's look at this line. It's this one right here. You can see my y-intercept is right here at 500. So this is where y would be 0. Or when my y is 0, this is what x, and when my x is 0, I'm sorry, then my y is 500. So I just plug a 0 in, and then that says when x is 0, y is 500. So that's a little bit of line plotting for you, taking you back there. And then the negative 2/3 is, for your slope, it's rise over run. So that means I go down 2 and over 3, go down 2 and over 3, and that's the slope of my line. For my polyester, if x is 0, then my y is 1,000, way up here, you can see. And then my slope there is negative 2. So I go down 2 and over 1, down 2 and over 1, and that's the slope of that line. And now you can see I have this great visual that shows where my lines are. And remember, we've got to be under that line. So I shade the area where I'm under both of those lines. And we just assume that our y and x are going to be positive because we're not going to have a negative number of pants. So for this particular problem, we can just assume that our axes are also our limits. And then I say that here, just that we have this implicit limit, no negative manufacturing. So now we know that our jackets, so we're going to bring in some other boundaries here. We know that we can't have any more jackets than 400. That was given to us. So we can draw a line at y, or our jackets are 400, and that's also going to create another boundary. And we know that our pants, we have to have a minimum of 200, and that's going to create a boundary right here at x equals 200. And so now this area here is what I'm going to call the realm of possible. To meet our constraints, our x and y points, our number of pants and our number of jackets has to fall in this area here. Now remember, when you guys are doing this in the business world and applying problems, you're not going to have to do this graphing and figuring all this out. This is just to really help you understand the concepts. The tool is going to make magic of this, and it's going to do all that under the hood just to give you the answer you're looking for. So here we go. This is the shaded area. And again, our number of pants and number of jackets have to actually be points somewhere in the shaded area. But remember, we don't want just any point. We want the maximum x and the maximum y. And we can actually visually see that pretty well and pick that out on this graph. But we're going to solve for it, and we're going to show you what the tool does when you have lots of variables to solve for. So the first thing we want to do is we make the equations equal, and where the equations are equal is actually where it intersects. So that point right there, which we can see visually here, is where they intersect and are equal. Once we make them equal, we can then, we made them equal based on the y isolation we did before. So this was one side of the equation and the other side, and we set them equal to each other because they were both y before. And we can then solve for our x. So you have one equation here and here, and now, similar to before, we want to isolate our x to solve for what is our maximum x here. And if we go through the process of getting x by itself, I'm gonna move this 1,000 over to the other side. So I add 1,000 over here, and that gives me negative 2x minus 2/3 x minus 500. And now I've got to get my x's all on the left-hand side, so I need to add 2/3 x to get it away from this side and bring it over here. And that brings us to negative 4/3 x equals negative 500, or when I divide by negative 4/3, it gives me x is 375. Now, once I have my x, where these lines intersect, I can solve pretty easily for my y. I can pick out either of those y equations that we came up with before, plug in my x, I picked the easier one, plug in my x, and then voila, I have my y is 250. So even though I could see it on the graph, this mathematically gives me the exact coordinates for my maximum x and y. So in an equation form, if we look at what is the solution for our objective, remember our objective function says that maximized revenue was however, $50 per pair of pants plus $40 per jacket, and what's the right number of those. And if I plug in my coordinates, it tells me that if I am able to produce that many, which we've solved for how much cotton and polyester we have and maximize that, I can plug that into my revenue equation and find out that on any given day, with the way my factory is constrained and the amount of materials I'm given, I can produce $28,750 in revenue. All right, so now we are done going back to high school algebra. We're done kind of going under the hood of how does this whole idea of optimization even work. And now we're gonna go over to the tool itself and start talking about how do I actually use this in Alteryx. All right, so I have to throw this picture in. So under the hood in the optimization tool in Alteryx is an algorithm that's open source called GLPK. And it stands for New Linear Programming. And what is New? New is an open source organization, which is kind of, I forgot what they call this kind of acronym, a repetitive acronym, where it just kind of keeps feeding on itself, where it says
Sorry, guys. Heather's reconnecting. Sorry, so she's dialing in now.
The Alteryx team, if you can confirm that you can hear me, and then I'm actually going to move over to my telephone once I get the number out of the meeting.
I can hear you, Heather.
Great. Let's go ahead and just get that number and get that dialed in. And I apologize to the audience. Thanks for your patience.
All right, I am now using my phone, so hopefully that will give us kind of some continuity there. Tubi, can you hear me okay?
I can.
Perfect, thank you everyone. We are back live. Welcome to the coronavirus world of unreliable internet at times. Okay, and it's not like I could just run up to my local Starbucks and use their internet. So here we are, we've talked through, we have a variable list. Let me see if I captured that on the screen. Yes, I have captured everything we're going to do on the screen. So we've gotten all the way down to our objective equation. So now you'll see that there's this constraint where we enter that. So if we go to the next screen, you can see that I click on constraint, and then I enter my equations one at a time, exactly as you see here. And Subi, is that coming through where you can actually see those equations entered pretty well?
Yep, I can see them.
Okay, I'm going to probably just not even try to screen share my Alteryx designer, which I think we can get by with for this particular session today. So I enter those constraint equations one at a time, exactly how we had them before with our upper limits on the right-hand side. And then the last thing are bounds and types. And when you come into this, it asks you what type of variable X and Y is. I don't have it on the screenshot, but your choices are, it can be a continuous, which really means any number, which includes decimals. Sometimes you'll have just integers. We do have in our equations some 1.5s and things like that. So we're working with continuous numbers here. And then this idea of binary or Boolean numbers, which may be appropriate for certain data types. And then we enter the bounds for those. So not only do we know that X and Y play into our cotton and our polyester limits, but we also know the factory told us that X has to be greater than or equal to 200 every day. And the upper limit of that is you can produce as many pair of pants as you want. So we'll put the notation here is plus INF for infinity. For the Y, however, we know we have to produce at least 0. We can't go negative on that. But they told us that the maximum number of jackets we can produce in a day is 400. So we put that down here on the bounds. So this is kind of the equation format, and this is what you would enter in the tool itself. And again, you just have this one tool on your canvas that you're working with. Okay, so now when I run it, all I do is I enter that, I hit run, and if I look at my simple data output, which is the S green on the right-hand side of the tool, this is what I'll see down in the results window. And voila, it matches our map. Our map was right, our objective value, in other words, our objective was maximum, and the maximum value is 28,750. And it solved the equations and told us, and by the way, that's when X is 375, so when you produce 375 pairs of pants, and when you produce 250 jackets. So with the materials I was given, this is the number of jackets and pants I have to produce in a day to get the maximum revenue. Now, I didn't capture it here, and I tended to show this in the live demo, but if you wanted, you could hit your slider to the left, and it will give you, you can actually just for fun see what's the minimum it thinks. If I needed to minimize, if I was lazy and I wanted to make the least amount of pants and jackets in a day, what would that be? Like what should I make with the materials I have? And it will tell you, and it will actually tell you the revenue, I believe was on the order of, let's say it was about 5,000. I want to say maybe it was closer to 10. I don't think I captured that on the slide. I did not. But it was closer to about 10, and what that told me was that there's an $18,000 difference between the minimum amount and maximum. And if you think about that over the course of a year and much larger business problems, that's going to add up day after day on my revenue. Just taking a look at what the data output gives you, that's the D coming off the right-hand side of the tool, is it really just marches you through the configurations that you had and the number of constraints. And it summarizes what's coming out of this particular algorithm, what your variables are, what your constraints were. So you have a nice summary, which when you get into more sophisticated problems with a lot of variables and a lot of constraints, it's nice to have this summary. And this can also be what I call a sanity check to make sure you've entered things correctly. If somebody's doing a design review with you and says, hey, I want to see what you entered in the tool, you can show them the input, but having a nice summary also helps with those reviews. And then the I part, it brings you to an interactive dashboard. And again, I've captured some screenshots, so good on me. I'm glad I thought ahead because I didn't know what kind of technical things we'd run into. So we'll show those. But this is really going to show you, let me just keep going and I'll show you what it gives you. When you click on the I in your results, you'll get an opportunity to hit a link that populates on the left-hand side of your designer interface. And it will show you this solution summary in a more visual, dashboardy looking format. It shows you what decision variables you have, and it also shows you the constraints. So similar to this, the summary output, but in a more visual way, so you can explore it. Okay, so now we walk through how would you do this manually. So I go into the tool, I actually go into my configuration window, and I enter those values. Now, how do I do it using a matrix? And just by the way, just a reminder what a matrix is, or matrices plural, it's just a table. And so we're going to talk about why you would want to do this and how you actually do it with the tool. And I believe I can show you, without showing you my screen, how we actually do it. But let's talk about why you would want to do it. Well, the problem we're solving today is pretty straightforward, just a couple of variables and constraints, and it was pretty easy for us to enter all that manually. And we also know our constraints aren't changing in this particular scenario. However, in the wild, out in the real world, your model might be a little bit more dynamic. It might be that you can produce more on Mondays and less on Fridays because of the delivery from your supply chain, for example, and what kind of raw materials you get. And so maybe we need to account for that in our workflow to like feed certain values in on any given day or on a schedule, taking advantage of, say, Alteryx server that can do a scheduled workflow with more dynamic inputs into this model. Or our constraints might change in a variety of ways. In this case, the constraints change based on the day of the week, for example. The more obvious one are, as you guys know in the real world, it's not so simple sometimes with what kind of variables we have. We have lots of things we have to consider, and we want to model that in a way that we can really leverage the power of Alteryx to help us solve this problem. In that case, the math model gets crazy complex and certainly not going to be working that out by hand. And the manual configuration would get super duper tedious there. So just to talk through the input anchors, so you might remember when we configured manually, we didn't even touch the input anchors. We just configured the tool itself. There were no input anchors required. When we're using matrices, we use the O for objective, and we use the A, and we will actually use the B in our case for constraints, for our constraint equations. So I'll just show you what that looks like. And then the same thing for a file, we actually, you don't have to use inputs as well. So let's look at the matrix input. So fortunately, I have enough on the slide that you can see that this matrix right here is what I would want for my objective equation, and this is the format it's looking for. So it needs to know that my variables are X and Y, and it needs to know what the coefficient was on my maximizing equation. And that's all it needs to know. It does need to know that it's continuous. So there's a type format here, and this is LB for lower bound and upper bound, so you might remember we entered those things. But now you could do this in a spreadsheet. So on this O, I can actually connect an input tool here and read in a CSV, or I can drag on the input where I can create the input inside Designer as well. Okay. Are we still live, Tudy? I just had a little hiccup on my machine, just checking.
Yep,
live.
I can hear you.
Yay. Thank you, cool. Yeah, that plugin was still kind of giving me grief for the screen share. Okay. So then our A input, our matrix input, this is really about your left-hand side constraint. So you might remember, so now the O is about your maximizing equation or whatever you're, if you're minimizing, it would be that. The A is really more where we're starting to enter our constraint. And in this case, the tabular form is you list your variable and you create the different aspects of your constraint. So we had cotton square feet and polyester square feet. And we enter it here. And if you look at our equation, remember we have our constraint equation, x plus 1.5y is less than 750, and 2x plus y is less than or equal to 1,000. The A is really about capturing the left-hand side. In the next slide, I'm going to show you how the B is about capturing the right-hand side. So this is the left-hand side of that equation. When we go to the next slide and look at the right-hand side, we have to transform our brain a little bit, and now these become our, the right-hand side is now in a columnar format, so it's kind of a transpose view, if you will, but it's less than or equal to 750 and less than or equal to 1,000. So you can actually think about this lined up with your other, the other constraints we just came up with, except that it's listed a teeny bit differently. But the key thing is that they need to be in the same order. And we need to say this is the directional, so meaning less than or equal, by the way, as well. And that's the right-hand side of the equation. So again, I would either do this as a text input tool, or I could drag an input tool and connect to a CSV to provide this information. And so, yeah, because I'm going to see, you guys will be a little bit patient. I'm actually going to see if it will let me share my screen. I kind of was fussing with my plugin while I was talking and seeing if it would cooperate. And yay, we are going to have a little bit of Alteryx Designer here. So you guys can see it might take a couple of seconds to refresh. So now you can kind of see in the wild, this will give you a little bit better view of all the things that I was talking about, but how does it look in Designer? So on the left-hand
I can
side,
see it.
Yay, thanks, Tubi. Thank you, everyone. You can see on the left, in the left container, I have the manual input, and on the right, I use CSV. So let's just look in the wild. If I click on the tool on my manual input, it's all the stuff that I talked about, but now I actually can show you all the options. Hooray for technology. So here are the different options where you would pick if you're using matrices, manual, or from a file. And then we talked about linear program. Just so you know, there's other types of ways to model these that are a little bit more sophisticated. I will let you read up on those. And just as a friendly reminder, you can always enter in your help bar up here, and it will take you to the community, any articles, any help pages, any posts in the community around those topics. So just when you're in Designer, just remember you can always type those things up here that you're curious about, and it'll take you right to the community, which I absolutely love. And then I told you we're using that GLPK, which there is also another type of solver called Symphony. And again, I'll let you guys read more about that if you want to do that. Remember I told you we could minimize the objective or maximize. Let's run it with maximize just to show what I was talking about and how the output shows me that 28,750, but now I can actually show you when I go to minimize my objective, so I want to know what's the minimum revenue, and I run that, one would think 0, but I'll show you how it solves for it. So it actually, what it did was it said, I have this certain amount of material, so I'm not going to make any jackets. See, it came up with 0, but I'm going to make 200 pair of pants, and that value is going to be, it was right at $10,000. So that's $18,000 more a day. Let me flip back over so I don't trick myself when working with the algorithm and make sure that I leave it at max. But now you can see nicely the ways that we enter the objective here, the constraints here. You enter one equation at a time, and once you hit enter, it'll bring it down here, but you can remove as well. But this is where you add, and then the bounds and types here. And then I told you this is where like you pick what kind of variable it is. So now looking at the matrix version, if you look over here, you do see once I pick that the model is matrixy, then I'm still going to solve with a linear program, DLPK as my solver. I'm still maximizing, but then I tell it that I am entering my constraints in rows for anchor A, and for anchor O, I don't do a field mapping because I just enter them in order. But just to give you a flavor of like what my CSV looks like, you can see it's identical to those tables that I have in the deck. So now that you're able to download the deck from the On24 platform, it's a friendly reminder that you can download that deck for your reference later. You'll see that what I put in the deck actually matches here, and this is actually just a CSV that's being read in. The key thing to remember is make sure you label your headers what it's expecting: variable, coefficient, type, LB for lower bound, and UB for upper bound. Then for the coefficients in your equation, remember that's here. It does have to be variable for your first column, and these can be whatever you want to call them. And then your bounds are here. These also have to be labeled DIR for direction and RHS for right-hand side. And then you can see, if we look at our output, it is complete. Oh, why is my objective? Let me rerun. Did I do something wonky in my objective? Because I got a different value there. Did I enter a different equation when I was playing with this? I may have. So I can just verify that to myself and do a little sanity check. So you can see it's a little bit different. So let me just look and see that I was playing with this 50, 40, 200, 400. So I might have inverted something. So here's a good sanity check. I will go back because, as you guys saw, I just got a different maximum function here. And so my best guess is that, without debugging right here, is that I might have inverted one of my coefficients. So I will go back and play with that later. But you would, yeah, and then I'm also just making sure that I didn't pick a different solver. So just some sanity checks here, but it just does show you the format, and I will go back and figure out what I might have inverted there. The other thing I really wanted to show you was this cool interactive. So I told you coming out of the right-hand side of the tool is the I interactive, and if when I select that, it brings up this really nice interface. Now this is a simple problem, so it's pretty straightforward looking at this, but when you have a more complex problem, it gives you a really nice visual summary here. And I think that's really it. It's a one-tool wonder when you're doing this. And with a file format, you can, I'll just show you really quick. I didn't implement it here, but if I were to say from a file, then really what it's going to look for is I actually enter the file here instead of using an input tool. And that input file would have similar constraints to the order of your columns and information. And so you can look for that in the community as well, or in the help for the tool. So I am going to pop back over to my slide deck just to be mindful of time. TV, are we back to the slide?
Yeah, we're back to your deck.
Awesome. And so really, what I wanted to leave you guys with is just some resources that you can tap into. Sydney Furman is one of my favorite bloggers on the community. If you guys have an interest in data science in particular, go to the data science blog in the community, and she just has a great way of dissecting and presenting data science concepts for the typical, non-PhD data science type person. And she came up with a tool mastery article around optimization. So I highly encourage you. This one's under designer knowledge in the community, but I highly encourage you, if you want to really dive deeper into some of the stuff that I was talking about, Sydney wrote a really great tool mastery piece for you. And then the next thing is one of my favorite tricks in Designer is in the help menu. Let me back up and say, by the way, to use this, you need to install the predictive tool to get to this tool. And once you do that, you will actually, under help, get sample workflows for predictive tool samples. And this is under the predictive tool samples. And it's actually under prescriptive analytics, because the reason it's called prescriptive analytics is we are actually prescribing to the business, what should I do? We're saying, here's what you should do. Here's how many pants and jackets you should make every day for your business goals. And so that's why it's called prescriptive analytics. It's the what should I do? And so, but you'll see that there are actually 5 ready-built, runnable examples that you can get to. And by the way, I highly recommend this whole section of help, where it has just so many ready-made sample workflows for any kind of typical application. So, but there's plenty for optimization. And then I am also going to point you to a blog post I wrote in December, because I know that a large majority attending today are part of the Alteryx Adapt program, which are folks who are up-leveling to make yourselves more maybe relevant, or give you some new skills to take into the workplace, especially if your job has been impacted by COVID-19. And just for anyone that's on this, if that's happened to, I just want to say, I just encourage you to keep on keeping on. And I can tell you from experience with Alteryx that this is a darn good tool to get under your belt. I highly recommend you go get course certified for free in the community, and that is something you can put on your LinkedIn and a really amazing flag to wave. But if you also want to find out some new ways to use your newfound Alteryx skills to grow your career and build your brand as an analytics professional or a data professional, this blog post, you can search for it in the community. We'll give you a whole bunch of ways that Alteryx provides for you to do that. And then I just want to say thanks to all of you for spending time with me today. I hope this really demystified this whole idea of prescriptive analytics and prescriptive optimization. Please reach out to me on LinkedIn, definitely in the community. I will be doing a summary of this session in the community, and I would love to see each and every one of you. Just come say hi and let me know you were here live. Or that you're listening to the recording. So, and just introduce yourself. The community is such an amazing asset for you to have as well. And with that, I will just see if there's any questions that I can answer in these last few minutes. And I just want, while I'm doing that, I just want to say thanks so much to Jesse Chow and Christian Lopez and Rod Galgadigan. I don't think I said his name right, but they're all standing by here from Alteryx, helping monitor questions and answering them for you if they could throughout this. Janice, thank you so much for joining. I see, your comments. Thank you for telling me it was awesome. I hope you go use it and do cool things. Make sure you come and say hi on the community, okay? And Linda as well, I appreciate the notes about the examples being helpful for you. And I love this, you guys played along. Oh, and thank you, Linda was trying to solve my problem with what I did wrong on the matrices. So thank you guys so much for playing along and joining us today. And Patrick, thank you for the kind notes as well. I really appreciate you guys. And come say hi to me on the community. I'm going to do one more shameless plug for the community. There is an industry forum as well, and I've just started a video series where I'm going out and I'm interviewing 5-minute interviews with different Alteryx innovators out there, and they're talking about what they do with Alteryx in industry, and that can give you great ideas for what you can do with your new skills. And with that, I'll say goodbye. Thanks.
Thank you, Heather. That was great.